This tutorial covers the basic modules of PTB. It will help you get started. All the information provided here is given in more detail in the PTB user manual. After clicking the Access link, you will be prompted for a username and password. Enter those and the Open Scenario dialog will appear. Open the file use cases/medium transformation station.scn. The first screen to appear shows the network view. In this view, we can see the tasks, their dependencies, and status. The arrows between tasks indicate that a task at the start of the arrow has to be completed before a task at the end of the arrow can start. Currently, all tasks have a thin blue border because they have not been planned. In the top right corner of the screen, information about the scenario is visible. We can see that we currently have $130,000 in cash, the simulation time is 0, the due date or target finish period is 31, and the target cost is $90,000. Every time we run the simulation, we advance it by one or more time periods. Our goal is to finish the project in 31 periods at or below the target cost, while satisfying the cash and performance constraints. First, you must plan the tasks. Double-click the Manufacture High Voltage Switchboards task in the Network view. An expander will open in the bottom of the screen with information about this task. This task can be executed in one of 3 different modes. See the bottom of the screen. Each mode has an estimated duration, fixed cost, and required resources. Change the task status to Planned in the Change Status combo box. Subcontractor A is selected by default, and the default start time is 0. The color of the node representing the task Manufacture High Voltage Switchboards in the Network view should have changed to show that it is planned. At this point, you could manually plan each task or use automatic planning. We will choose the latter method. Click the Plan Default button in the Plan menu, in the Plan Execute Control menu tab, to plan all tasks. This plan sets all tasks to start at the earliest possible time in the least expensive mode. Now we have a plan for executing the project. This plan is not necessarily a good or feasible one. Run the scenario by clicking the Run button in the Execute menu, in the Plan Execute Control menu tab. Once you do this, the following message will appear. Not enough resources of type workshop workers. 1 unit is available while 7 are required. This message indicates that the simulation cannot run as currently planned because of a resource violation. The number of workshop workers required exceeds the number available. To see the resource availability and usage for resource type workshop workers, select the resource charts and workshop workers in the Resource Information menu in the Plan Execute Control menu tab. According to the current plan, the estimated finish time is 33. During all time periods, the available number of units of the workshop workers resource is 1, as indicated by the blue line. In periods 0, 1, and 2, the current plan requires 7 units of workshop workers, which is why the resource violation message appeared. By clicking the first time period, the tasks that use this resource are shown. There are 3 options for fixing the resource violation. 1. Assign more workshop workers resource units. 2. Delay some tasks using this resource. 3. Change some of these tasks to a different mode of operation that uses less of the workshop workers resource. By going back to the Network view, Network button in the General Information menu, in the Plan Execute Control menu tab, and clicking the Manufacture High Voltage Switchboards task, we can see that currently the selected mode is Subcontractor A. This mode requires 5 workshop workers resource units. Change the execution mode to Subcontractor C in the Mode combo box, as this mode requires only 2 workshop workers resource units. This change reduces the required workshop workers units from 7 to 4. However, we still have only 1 unit available in the first time period. For the Manufacture Low Voltage Switchboards task, the mode that uses the minimal amount of this resource is already selected. Let us try to solve the problem by assigning more workshop workers resource units. Click the Resource Chart and Workshop Workers button again. Additionally, click the Resource Information button in the Resource Information menu in the Plan, Execute, Control menu tab. Now only 4 units of workshop workers are required. We can also see information regarding each resource type. The maximum number of allowed units for this resource type is 7. To assign 3 more workshop workers units, select Workshop Workers in the Select Resource combo box in the bottom part of the screen. Then, enter 3 units in the Assign text box and click the Assign button. You will see that after assigning the additional units, you will have 4 units available throughout the project. However, in the first time period, you will still only have 1 resource unit of this type. This is because of the assigned lead time of 1. The problem in the first period remains. We have no choice but to postpone the 2 tasks requiring this resource. Click the Gantt Chart button in the Plan menu in the Plan, Execute, Control menu tab. In this view, you can see all the tasks and their status on a timeline. It can also be used for planning tasks. You can see the task details by double-clicking on it. Open the task information for the Manufacturer Low Voltage Switchboards task by double-clicking on it. Enter time 1 instead of 0 in the Start At text box. Then click the Apply Start Time button. Another way of changing the start time of a task is by dragging it in the Gantt chart. Drag the Manufacturer High Voltage Switchboards task to start at time 1 as well. Now go back to the resource chart. You will see that in time 0, no workshop workers resource units are required, and that in period 1, 4 units are required, which is exactly the amount available. Now run the scenario again by clicking the Run button. You will see that now the run was successful. Simulation time changes to 1. To see the changes in the cash position, click the Detailed button in the Financial Information menu in the Plan, Execute, Control menu tab. You can now see detailed budget information. In this view, you can see past, actual, cash flow, and future, expected, cash flow details. We can see that the cash changed to $129,700 after running 1 time period. In this period, the costs were $300 due to an idle resource cost. Only the construction task started in this time period, and this task has no fixed cost. The task also requires no resources. It is an outsourced task, so all the available resource units were idle. These units are 1 workshop workers, 1 LT worker, and 1 HT worker, each having an idle cost of $100, which sums up to the incurred $300 cost. The total estimated cost of the project is $102,490. It exceeds the target cost of $90,000, as seen in the upper right corner of the screen. The estimated cost is colored in red to signal the cost overrun. In a similar way, the estimated finish time of the project is colored in red, as it is 33 time periods, while the target period is 31. Run the scenario for a few more time periods. In our case, we will run the simulation up to time period 3, but this might not be the case in your simulation as we introduce a random, uncertain event. In the next time period, the task requires 4 workshop workers units. However, only 3 units of this type are available, because the probability of each workshop workers unit showing up is 95%. This means that there is a 5% chance that each unit will not show up at any given period. This is a random process, and every time you run the simulation, this can happen at a different time period. If the tasks using this resource, manufacture high voltage switchboards and manufacture low voltage switchboards, had not yet started, you could have postponed them or changed their mode of operation. However, since they have already started, one task must be split. Splitting a task means that the task is paused and then resumed later on. Splitting typically has an associated cost. Another source of uncertainty is the task duration, which is a random variable. The actual duration is randomly generated between the optimistic and pessimistic estimates. To split a task, click the Manufacture High Voltage Switchboards task in the Gantt view and enter the current time 3 in the Split At text box and the time 4 in the Restart At text box. Then click the Apply Split button. We can see that the task is split in the Gantt chart. Now change the resource chart view again to see that there is no violation and that the run can continue. Remember that splitting a task typically has a cost associated with it and should therefore only be used as a last resort when the scenario cannot be run otherwise. So far, we have discussed the project goals in terms of project cost and project duration. The third important goal deals with the performance of the system delivered by the project, or the system requirements. Each project can have any number of defined system requirements. To view the system requirements, click the System Requirements button in the General Information menu in the Plan, Execute, Control menu tab. This project has one defined system requirement: reliability. The desired value is 70. Your goal is to maximize this value. The evaluation according to the current project plan is 13.68. By using interpolation, we translate the value of 13.68 to a score of 19.54, measured between 0 and 100. The requirement is defined by a formula, a multiplication of the quality parameters TR, RHTS, RLTS, RHTL, and RLTL. When you create a plan for the project and select modes of operation for each task, the quality parameters receive a value according to the selected mode, and the system requirement is evaluated according to the values and the formula. To see which task affects each quality parameter, click the QFD button in the General Information menu in the Plan, Execute, Control menu tab. For example, you will see that the Transformer Reliability, or TR, quality parameters value is determined by the mode selected for the Install High Voltage Transformer task. Now click on this task in the Gantt view and you will see that in the currently selected mode, Subcontractor B, the TR quality parameter receives a value of 0.5. Change the mode to Subcontractor A by double-clicking on it. Now TR receives a value of 0.8. By clicking the System Requirements button again, you will see that the evaluation of reliability changed to 21.89 and the score increases to 31.27. This is an improvement. However, it does not yet meet the required value of 70. More modifications to the plan are necessary. Changing the mode of a task has other implications on the project, possibly affecting the cost and duration. If more than one requirement exists, the requirements are ranked based on their importance to the stakeholders. Each requirement is assigned a weight of between 1 and 10. The normalized weights are used to calculate the total benefit of the system defined as the overall sum of the weights, each multiplied by the corresponding score of the requirement. The benefit of the system is displayed along with other performance measures of the project in the upper right corner of the screen. When creating a plan, it is important to verify that all the constraints are satisfied. The PTB supports the lean project management approach that focuses on maximizing the value of the project to its stakeholders while minimizing waste. The lean indicator is displayed by clicking the Lean Indicator button in the Control menu in the Plan, Execute, Control menu tab. The report is divided into 4 parts. The upper left quartile of the report displays the benefit of the system delivered by the project. The benefit is defined as the sum of all the requirements, each multiplied by the corresponding normalized weight. The upper right quartile of the report displays 2 sources of waste: the waste generated by idle resources and the waste generated by penalties due to delayed project completion. The lower part of the report focuses on the goals and constraints of the project. The lower left quartile of the report displays the constraints on project duration, the time constraint, the constraints on project cost, the cost constraint, and the constraint on cash availability, the cash flow constraint. The lower right quartile of the report displays the status of the requirements. If a requirement is satisfied, the statement "satisfied" will be displayed in green next to it. If a requirement is not satisfied, the statement "not satisfied" will be displayed in red next to it. In case the evaluation of a requirement is better than the desired value, the statement "satisfied with overdesign" will be displayed in orange to present a potential overdesign or gold plating waste. In our case, the time and cost constraints are not satisfied. Additionally, there is significant waste. Try to improve the plan by reducing the time it takes to complete the project, by reducing the overall cost, and by improving the project's benefit. You are now familiar with the basics of PTB. More options not covered by this tutorial exist. For more information, see the user manual. In the tutorial, the selections made were very naive and probably not very good from a project management point of view. A much better solution for the project can be achieved. Some better practices would include considering the trade-offs between cost, duration, and quality when creating a plan for the project. Reducing the resource violation risk by buffering or having more resources than actually necessary if the resource type has a low show-up probability. Releasing excess resources. Identifying the critical path and paying more attention to the critical tasks. And verifying that the future cash flow does not run negative.